Now listen, I know this has been an awesome and long first day of reInvent, and we are likely the last session between you all and your first reInvent happy hour. So we appreciate you sticking with us. We're really happy that you're here today, and we'll do our best to make this one fun, and more importantly, make it fast so y'all can get out of here, enjoy that beverage, and maybe have a nice dinner. Alrighty. Quick round of introductions, just so you know who we are. My name is Kevin Coleman. I lead the worldwide go-to-market team for Kubernetes at AWS. I'm joined today by my colleague, Roland Barcia, who is the Director of Specialist Solution Architecture for our containers and serverless services at AWS. And we're also super lucky to have a customer speaker with us today, Ahmed Bebars from the New York Times, who's going to be talking about the awesome platform that he and his team are building on top of EKS. All right, the quick agenda for today. To start off, I'm going to share some of our perspective on how we view platform engineering in the EKS world and some of the benefits we see customers realize with their platform engineering investments. Next, we're going to touch on a few specific customer examples. And I'll share two different examples of customers who are kind of at opposite ends in the maturity spectrum with their internal platform that they're building. After that, I'm going to hand the mic over to Roland. He's going to come up here and talk about some platform implementation patterns that we see among EKS customers. Then he's going to jump into best practices. And for the folks in this room who are currently building internal platforms on platform engineering teams, this is where you're likely going to want to pay attention. In our roles, we get to work with a wide range of customers across the globe who are building platforms on top of EKS. And there's been some key learnings that have emerged from all those engagements. So Roland's going to share some of the salient learnings, and hopefully those will help you with your platform engineering endeavors. Finally, Ahmed's going to come up here, and again, he's going to talk about the awesome platform he and his team at the New York Times are building on top of EKS. All right, that's a packed agenda. Let's get into it. So what is platform engineering? Before we jump into this, I want to see a show of hands. How many folks in this room are platform engineers today? All right, great. I expected a good amount of hands. How many folks are DevOps, SRE types? OK, wonderful, good mix. And how many folks are leading platform engineering organizations or otherwise responsible for enabling cloud adoption at their companies? All right, wonderful. So if you are leading platform or cloud adoption at your organization, you are responsible for enabling your organization to run applications in the cloud. This can include migrating, it can include modernizing, it can include building net new. But you will have a wide range of internal customers who are software development teams. These internal customers will likely be responsible for building or maintaining a wide range of applications, maybe one, maybe many, maybe a portfolio of applications. And those applications will need to run on a wide range of cloud infrastructure services in the cloud. This, of course, will include services, compute services like EKS or EC2, but it could also include things like storage or databases or networking and monitoring services. Additionally, not every application is going to be the same. They have different requirements. They are heterogeneous. Some might require more compute than others. Some might require more memory. Some might require GPUs. But regardless, all of these applications will need to run in the cloud. And you, as the leader of the platform organization or the cloud adoption organization, are responsible for figuring out how to do this, hopefully in a somewhat cost-effective manner. You all have a choice to make. Who is going to be responsible for managing the infrastructure that is going to run those applications? And I like to think about this choice along what I like to call the infrastructure management spectrum. So on one end of the spectrum, you can choose to decentralize infrastructure management responsibilities. In this model, the application teams that build the applications will also be responsible for deploying and maintaining the infrastructure that is needed for those applications. The implication here is that each individual application team will be responsible for deploying, maintaining, and perhaps most importantly, troubleshooting production-grade infrastructure that is needed to run their applications. On the other end of the spectrum, you could choose to centralize infrastructure management. In this model, there are central teams that compose infrastructure services into platform abstractions, which are then offered as a service to application teams, allowing them to offload their infrastructure management responsibilities. Platform engineering conceptually skews towards the left side of this diagram. It is all about building abstractions that allow application teams to offload infrastructure management responsibilities so that they can focus on building their applications and delighting their customers. However, in the EKS world, the abstractions that we see customers building and the customers that we work with actually vary significantly and fall at different points along this spectrum. And the reason for this is that application teams and organizations have different requirements. Some application teams actually want to have some infrastructure control. Other organizations might not allow them to have that control because they have various compliance requirements. So to zoom in and be a bit more precise, we view platform engineering as the practice of identifying and building compute abstractions that meet the unique requirements of your internal customers and your organization to enable the efficient, cost-effective, at-scale adoption of the cloud and ultimately accelerate software delivery. All right, so let's talk about abstractions for a moment and why they're so valuable in the cloud context. And I think this is a really great visual to illustrate the point. On the left, on the right, you have a bunch of parts for an engine, which you can think of as representing cloud infrastructure and infrastructure primitives. And on the left, you have a complete engine, which is sitting in a car. And you can think of this as platform abstractions. So of course, there are a number of people in the world who are capable of taking parts of an engine, assembling them, building a complete engine, and installing it in the car. But it is labor intensive, it takes time, it's complex, and there are a much larger number of people in the world who just want an engine installed in their car, get in the car, turn on the key, and drive away. In the platform engineering context, of course, there are plenty of people who can compose infrastructure into complete abstractions that are needed to run applications. Many of you all are sitting in this room, and you have the skills that can do that. But there's a much larger number of application and software developers in the world who don't necessarily want to, nor should they need to worry about composing infrastructure into the complete holes that are needed to run their application in the cloud. So they just want to get back to, again, building their application and focusing on their end customer. Platform engineering is really the practice of building abstractions that meet your customers where they are, your internal customers where they are, and allow them to offload infrastructure management responsibilities so that they can focus on their end customer. All right, so we've talked about building abstractions and platform engineering. Now let's talk about internal platforms as a whole, because it's more than just infrastructure abstractions. As I was preparing for this talk, I came across this definition of an internal platform, and I really like this, so I wanted to share it with you all today. An internal platform is a foundation of self-service APIs, tools, services, knowledge, and support, which are arranged as a compelling internal product. There are two parts to this definition that I really like. First, this definition doesn't just touch on the things that platform engineering teams build, the APIs, the services, the tools, or the abstractions. It also touches on how they drive adoption of the things they build through knowledge and support. The most successful platform teams that we work with in the EKS world do a really good job focusing on things like documentation and providing support and education for their internal customers, which serves to drive adoption of the abstractions in the platform that they build. The second part that I really like is the last three words, compelling internal product. When we build internal platforms for our customers, our internal customers, we really do build a product. It's the same thing we would do for building a product for external customers. So the teams that we see in the EKS world who have the most success with their internal platform endeavors really take a product-centric mindset to building their internal platform, work backwards from their customers, and build abstractions that meet their specific needs. All right, so building a platform is an investment. There is an upfront cost that will hopefully pay dividends over time. So let's talk about some of the benefits that we see customers achieve in the EKS world who have success building internal platforms. So the first thing we see is velocity. And this really comes down to speed. Customers, via their internal platforms, are able to reduce the time it takes to get innovative new ideas and code, literally code from a developer's laptop out into production and in front of customers. By removing the need for each individual team to provision their own infrastructure, and by providing self-service deployment capabilities, companies can accelerate and do accelerate time to market for new ideas. The second is governance. And in this context, governance is sort of a catch-all for things like security, reliability, scalability, et cetera. By building abstractions, companies are able to enforce the requirements for these types of concerns in an automated way for all applications that run on the platform. So every workload benefits from sensible defaults built into the platform, and application teams don't have to figure out how to configure these on their own out of band. And finally is efficiency, and this really comes down to cost savings. And there's a number of ways that platforms can save customers cost, but I'll cite a few specific examples that we see quite frequently. In a multi-tenant, specifically a containerized setting, by building a platform, you can run multiple workloads from different teams on the same underlying host instances, therefore allowing you to be more cost efficient with your workloads. And the second one is from a human capital cost perspective. By removing the need for every individual application team from having infrastructure expertise in the team and centralizing that expertise, you're able to save on human capital cost as well. One of the things we hear quite frequently from customers, platforms empower companies to achieve economies of scale in the cloud. As I mentioned before, there's an upfront investment to building a platform, but once it is in place, the marginal cost of deploying or onboarding each subsequent application becomes quite small, thus enabling customers or companies to realize economies of scale. All right, so who's doing this? I wanted to share two specific customer examples of some EKS customers who've had success with their internal platform initiatives. And I wanted to share customers on opposite ends of the maturity spectrum. One is quite mature and has a platform that runs at significant scale today. And the other is earlier on in their platform journey, but have had some early success, and frankly is a very cool use case that's built on top of EKS. All right, so the first customer I want to talk about today is Salesforce. Salesforce's internal platform, Hyperforce, is built on top of EKS. Hyperforce is a reimagination of Salesforce's platform architecture built for the public cloud. And in 2023, importantly, it's how Salesforce is delivering trusted AI to their customers. The compute foundation of Hyperforce is called the Hyperforce Kubernetes platform, and it's built on EKS. With HKP, Hyperforce Kubernetes Platform for short, HKP, Salesforce engineering teams don't need to provision EKS clusters themselves. Rather, they're empowered to consume Kubernetes as a service. HKP streamlines developer experience and offers varying levels of abstraction, including vending clusters as a service and vending namespaces as a service for workloads that make sense for a multi-tenant setting. Today, Salesforce runs HKP across the Hyperforce fleet, which comprises over millions of pods and over 1,000 EKS clusters. So again, a customer that is running an internal platform at some really awesome scale and having a lot of success and seeing results because of it. The second customer I wanted to mention is NASA. And this is a customer who's earlier on in their platform journey. NASA chose AWS to serve as a foundation for their new data platform. Their platform is built with tools like Jupyter Hub, Dask, Crossplane, FluxCD, and the platform allows scientists to provision complete batteries-included Jupyter Hub environments in minutes. The new platform aims to enable scientists from around the world to collaborate by sharing data and processes and generate reproducible results. The ultimate goal of the platform is to provide scientific models as a service, or a way for researchers from around the world to execute common scientific models from a familiar interface. I think this platform is super cool because it supports the White House Office of Science and Technology's Year of Open Source initiative, which is a movement that aims to make scientific research more equitable, transparent, accessible, and collaborative. And we're super thrilled that the NASA folks chose to build this platform on EKS. All right, with that, I'm going to hand it over to Roland, who's going to talk about platform implementation patterns.
Thank you, Kevin. How's everyone doing? All right, almost beer time. Who's going to have a beer right after this in the expo? All right. All right, so Kevin asked how many platform engineers and DevOps teams there were. How many developers and app developers are there that are building apps on a platform? See, that's a problem, right? Where's your customer, right? So one of the veins of the existence of our team is this notion of what developers and data scientists want. They want freedom. They want autonomy. They want to use Jupyter Hub. They want to use Ray, Kubeflow, whatever framework they want. They want to build code. They want to deploy microservices. And they want the freedom to do that. On the other side, you have platform builders. And platform builders are trying to do the things that Kevin talked about, right? Which standards, governance. If you go too far in the standardization world, you build a platform that nobody uses. Developers are like rivers. They're crooked. They take the path of least resistance to get the job done because they're trying to meet a deliverable, a deadline. Sometimes you're even outsourcing development to different teams, and they got to meet that deliverable, right? You go on the other side, developers, you give them too much freedom, and all of a sudden you expose some URL out to the internet, or they start using up all the GPUs that you allocated for those new large language models, or they do all sorts of different things like ramp up the cost, and you see your AWS bill, and you're like, oh man, I didn't anticipate these billion events coming into the system to scale up this way, right? So how do we solve this? So over time, when you're starting to modernize, we usually start autonomous. You've heard Amazon talk about 2 pizza box teams, building applications. You have these independent squads. Now we have things like micro front ends, talking to microservices, talking to data meshes that are own data products, and people have this autonomy. You start building more and more of these applications. We spent the beginning of this year really focused on cost optimization, right? When the economy hit, we saw a big uptake on these platform teams saying, help us optimize cost, help us use things like Spot in a Kubernetes context with something like Carpenter. And then Gen AI hit, the hype, the wave. People started creating data platforms, and these same platforms needed to quickly spin up capacity storage GPU. And so you had both sides of it. And so let's talk about some of the areas that we see our customers have challenges with. And so first, ownership. I was at a customer meeting over in Europe. And in that customer meeting, we had a platform team, about 25 developers dedicated to the platform team, supporting about 200 to 300 application developers, different projects. And they had a pretty good platform team. They built automations across all their different capabilities, but they still had some issues across different teams. They had one team that was in the room with us, the developers were there saying, just take my code and deploy it and run it. We had another team that's like, I want my own cluster. I don't want you, I want my own isolation. I want to manage it myself. They couldn't make everyone happy. So we have this notion of who owns it, the platform. And sometimes the platform itself, people don't realize, is a product. If you're going to do platform engineering, you have to treat it like a product. And you have customers. Those customers are the developers and the data scientists. So when we build products, we build them for them. So are they included in there? The next area we see is level of abstraction. So we have everything from I want an AWS account, I want a cluster, to just give me a DevOps pipeline that I can push my code to, and that's it. We have a lot of variability there, and customers are struggling with where the line is for their organization. I wish I could tell you there is a silver bullet to say, this level as a service is the correct level, and all your platform issues will be solved. The other one, if you build it, they will come. Right? Field of dreams. The adoption problem. I've had customers come and say, hey, I built this platform, I've invested in it, it's really good. You should see the code we wrote. Super automation with all sorts of GitOps. You know, you touch my Git repo and nothing gets through unless my pull request gets accepted, and developers are not using it. And we have the other end of the spectrum. They get there and I say, hey, I built this platform. And with this platform, you don't have to know anything about Kubernetes, you React developer. Just go and check in your code. Trust me. I'm going to deploy your pod. I'm going to run it. Oh, your app is broken. It's your fault. Here, just do kubectl pod logs and go. Like, wait, you just told me I didn't have to know Kubernetes. What are you talking about? Observability is often an afterthought and not part of the platform design because we're wired to create. We want to create, provision, automate. We kind of center there, and then we realize that you probably create something once, you iterate, debug all the time. So where is the center of gravity for your developers and your users? Is it in building apps, or is it in maintaining your code, versioning your code, troubleshooting your code, debugging your code? Where is the center of gravity? It's the second part. So you might get people to initially onboard to your platform and then all of a sudden be looking for different places to go to because they can't troubleshoot, they have trouble accessing their logs, they don't know what's going on, it worked in their laptop, but not in the cloud or in the cluster or in the pod, etc. Everything from, I moved this application, and this was in the same customer meeting, from a VM, an EC2 instance, into a pod. Go over to the next slide, actually. Right? And they were like, okay, I sized it the same way, and all of a sudden, my app didn't run. And it's because other pods from other applications were scheduled on the same nodes. So they're like, uh-oh, this is broken. I need my own cluster. So the reason the developers were like, I need my own cluster, was they need isolation. What do you mean by isolation? There's 20 different definitions for what I mean by isolation. Everything from, I need my own AWS account with my own permissions. We have regions. We have reasons that we want to do multi-region for resiliency, availability zones. If you work in regulated industries like in public sector, you have things like network segmentation, and you need isolation from that perspective. I want my own cluster. I want my own compute. There's all these different reasons. In this case, it was really a troubleshooting issue that led them to the conclusion that that team needed their own cluster. What they really needed were their own nodes, their own ways to do scheduling, etc. But these are the things you need to tee off. And so there's a lot of different design choices that we go through with our customers. Everything from account as a service to template as a service, cluster as a service, namespace as a service, and platform as a service. We'll talk about that. How many folks here are doing one of these on the screen? Okay. Platform as a service, namespace as a service, cluster as a service, template as a service. Okay. So you see, you don't all agree. So we don't have the magic platform. All of these have trade-offs and downsides, and they're optimized for it. And it really depends on the workloads that you're supporting. All of these have a downside. For example, just had a meeting this morning with a customer in an EBC, and they have account sprawl. So all of these have sprawl issues, right? I can have account sprawl. I can have tons of old templates, unused templates that are sitting in a Git repo and never used. I can have cluster sprawl. I can have lots of unused namespaces, et cetera. And I can have lots of pipelines. So all of these have that issue. So you have to really think about what are you designing for. So the punchline is no one size fits all, right? It's very difficult. So what do we do about that? So one of the things that I think is important is this product mindset. If you're going to do platform engineering, it's one of your most important products in the organization. If it needs to support all of your organization's workloads, ML pipelines, data, and you need to work backwards from the business domain. At the end of the day, people are writing applications that serve a business function. You need to work backwards from that. So how do you think about things architecturally? I like to think of big buckets. So architectures, modular. You want two-way doors. You want to be able to have modules that you can build out, reuse. Developer interfaces. Oftentimes, we wish developers just use GUIs, but at the end of the day, there's a lot of automations that they want to support. What does your developer lifecycle look like? Data and dependencies. This is where there's often a lot of variability. shared databases, your own database, who owns the database, et cetera. And then you have libraries, reusable code, code libraries, reusable images, software delivery and automation. We're going to go deeper. And then simplifying the developer experience. And so as we go more to the right, the developer and the data scientist, and we break these down. The developer talks about containers. They have code. They have APIs. They have events. Event-driven architecture is something that people are building inside of containers, maybe integrating with Lambda functions. Then you have your code and your configuration. Configuration hell is a real place. People have been there. They can get out. They behave. But configuration. Then you have all sorts of dependencies. You want to think about this when you're building platforms, working backwards. How do I handle databases and machine learning tools? Libraries, brokers. You might be doing something with RabbitMQ, Kafka. How many folks are running Kafka? How many people are running Kafka on EKS? Okay, a few. All right. Automated software delivery. These are what we call, I like the ilities. We debated this word, Kevin and I, the other day on the phone. He does not like that word. He liked another one, but I won't say it. But we think about how DevOps pipeline, some organizations, I had discussion this morning with an organization that's separate organization for DevOps pipelines, the CI/CD pipelines for the developers, and their infrastructure as code. So that might be an additional customer. It might be part of the platform. That's the abstraction. Testing is often overlooked as not part of the platform. Security. Security is a day one for us. And so that needs to be part of the platform and observability. And then lastly, simplifying the developer experience. And it's really, how do I get to self-service? How do I give the developer autonomy? Templates, or maybe a mechanism to allow developers to contribute templates that work. And everyone's favorite development activity is documentation. How many people love documenting their code and their scripts? All right. Self-documentation, that's good. Automating it. Yeah. Awesome. And so, big leap here, but when you're building a platform, you have a lot of tools, a lot of choices. So we have clusters, shared services, all your ilities, and all the tools behind them. And you can build platforms with a lot of tools. Since this is EKS, a lot of the customers that we see using Kubernetes don't just think about Kubernetes as a compute, but as actually an API. An API that you use to provision, scale, secure, etc. And in this case, this is an example that we've done with quite a few customers where we have a management cluster built with something like Argo CD, OPA for your policies, Crossplane, or something like AWS controllers that enable you to provision managed services like a managed RDS database, an SQS queue, an S3 bucket. We have all sorts of different control plane aspects, and even the ability to use something like Crossplane to create, provision, and upgrade clusters. So this is going all in on Kubernetes. Now, do have a session, a chalk talk later this week, Con 408. It's called Infrastructure as Code versus GitOps versus CI/CD, because there's different choices. You can use tools like Terraform, you can use Pulumi, we have partners, et cetera, to do the cluster part and maybe GitOps to the right. I've had infrastructure teams come to me and say, I don't even know how to use Git. That's something developers use. You're not going to be successful at GitOps if you don't know how to use Git, security with Git, because it leverages all these things. So there's all the tooling choices. But again, you really want to go with thinking about all these things and what supports these big buckets, working backwards. So in summary, one of the biggest mistakes that we see with building platforms is they build something without any sponsors, any workloads. We always see the most successful platform teams have sponsored projects, customers that do things well internally, 2 or 3 workloads, that you build the platform together with your customer. Make the developers and the engineers part of that journey and build with them. So that's probably the number one success factor. Don't boil the ocean, but build with those use cases, pick compelling use cases, and work with your developers, maybe a stateful, stateless workload, something with some capacity, something with some requests, and build it out. Provide escape hatches. So this is 80% of your organization maybe will use the easy button, code as a service, but then think about, hey, if you want a little bit more control, we'll give you control with these different sign-offs, read this documentation, documentation as a service, and we'll give you escape hatches, cluster as a service. So don't pick one, pick 2 or 3, and have a priority based on use cases, and learn to change where that wall is, because what is default today might not be default tomorrow. Again, one size doesn't fit all workloads. Lastly, documentation and education are actually a key part of our platform journey. We run something inside of AWS called Technical Field Communities, TFCs. Actually, it was encouraging. I met with a customer this morning that's actually emulating that as part of their platform. So they've actually built enablement and education as part of that platform journey. Say, you want people to use the platform, come. We'll educate you. We'll make you Kubernetes developers. We'll help you get your certification. Think about draw cards to draw them in, and think about what they want to do. So that's where we're at. And with that, oh, one last thing. Shameless plug. Forgot we got this in here. We have a new EKS badge talking about education as a service. You can go get some learnings from some of the folks on our team from the field that work with customers in our service team. So if you want to earn this badge, we just launched it this week. Here is the QR code. Give you a second to take a picture, because we love getting educated. So we're putting our money where our mouth is. Get educated with EKS, earn a badge. And with that, Ahmed, you're up. Thank you.
Thank you, Roland. Hello, everyone. I know I'm the bottleneck between you and the reception, so I will try to be quick. Roland and Kevin shared great insights about how to build a platform on top of EKS. So let me start by how we built an internal developer platform at the New York Times. So as you know, the New York Times, the most recognizable product is news and journalism, but we also have other products like games, Wirecutter, audio, The Athletic, cooking, and others. So how we take all of these products and innovate and just deliver them. So when we think about this, let's discuss our motivations on building an internal developer platform. First, we think about like how to deliver a consistent experience to our engineers. So a new engineer is joining a team, they need to get like a consistent experience, while like other engineers in different teams get the same experience every time they try to build a new service or an application. We don't want to be a bottleneck into the software development lifecycle. We don't want to like to have like a manual intervention every time an engineer tries to deploy a new service or build a new service. So we want to offer this via self-service approach that allow teams to be autonomous and build using the capabilities that they need. Also, we want to provide an extensible tooling. What I mean by that is we don't want to specifically focus on the tools. We want to build an abstraction layer that provides teams with autonomy on building on top of it. So if we didn't deliver a specific tool for that use case, they can take that layer and build on top of it. At the end, like delivery is important, so we want to reduce the time from like ideation to production and allow teams to reduce all of the management overhead and infrastructure sprawl across the organization and get their bootstrap applications quickly. So I would love to talk about this quote from Daniel Cassidy. He's the senior product manager for the platform. Well, I would read it here. Engineers deserve a seamless experience to solve problems and deliver value. Imagine a centralized developer platform that helps engineers at every stage of the development lifecycle while reducing the burden of sprawl of infrastructure. So what he means by that is basically simple. Like when you go try to deploy an app, you don't have to focus on like all of the infrastructure necessary to deliver your app. Like you should go through a consistent experience. You don't have to ask anyone about how you would deploy it or all of the necessary steps for it. You should have this documented in a good way that allows you to build on top of it. So what makes an internal developer platform indispensable for an organization? So to address this, we identified a few core pillars for the platform. First, standardization. We need to make sure that we deliver like a standards across the organization that teams can build on top of it. Then efficiency, what I mean here is that like we have a seamless experience that we can deliver and we reduce all of the time and allow teams to deliver faster when they need. Integration, like the platform has to deliver a cohesive experience and integration with many tools. And here, like we need to have all of these tools integrated and deliver value overall to the development experience. Scalability, I don't mean here scalability by just the runtime experience. I mean scalability for the product itself. Like it's done in iterations. So like we built for day 0, day 1, day 2, and we continue going and add more features. And at the end, we have the visibility. When we share like a centralized internal developer platform, we can have like a full cohesive look into the entire infrastructure that we have and the portfolio of services that we deliver on the platform. And now, we've been talking about the internal developer platform, but let's talk about the customer themselves. So who are we building this for? So we are building this for developers or engineers. So like developers have a journey like a customer journey. Think about when you try to buy something, you go search for it, check out, and get it delivered, and then put it somewhere or use it, all of that kind of stuff. So developers have a similar journey. When they get a requirement, they start to think about how to solve the problem. They design it, plan it, and then they go through the process from coding to delivery. But what I did here is just like I focused on few elements that we can take these elements and abstract in the platform and make it easier and seamless for engineers not have to think about it. It's not necessarily that we want to abstract these away, but we want to deliver a cohesive experience and transition to make it easier for them to develop their applications. So before we transition into the actual workflows that we built, so we took the developer journey and we tried to transition this to our workflows on how engineers will use that, I want to iterate on the goal. So our ultimate aim is to assist engineering seamlessly in developing and delivering their applications, ensuring a smooth and seamless transition. So first, with the creation process, like as an engineer, you have an app you want to deliver to your customer. So you start create an app, onboard it, get all of the templating that you need from like GitHub repo or source control or any other Git control to a CI/CD, build and test and deploy. And then you get the runtime and the cloud resources that it's necessary here. So like you get all of that by you just like requesting it. You specifically say like, hey, I need this and this and this, and you click yes, that's what I need, and you get all of this out of the box. How we connect it at the end, we have our routing layer, which is a shared ingress model that we built in the company that allows you to serve all of your traffic to customers. But there's one missing piece here, which is observability. It's a critical piece. So as you can see, the observability layer here is across all the steps. So we need to ensure that every workflow is observed. And we have like a ton of telemetry data from traces, logs, metrics, and all of it's necessary to understand the entire workflow and lifecycle. So how we built that? We experimented with few approaches on how we built the platform itself. And we landed on like building on a multi-account architecture. So what does that mean? And instead of like layering all of the resources that we need into a single AWS account, like we start to think about like how to deliver this experience through a multi-account architecture. So why we would do that? Basically, we would get like group of workloads in specific accounts, like security measurements to ensure like development and productions are not in the same accounts. Also from a cost management perspective, to ensure that we understand what type of workloads sitting on which account. So here we have like the platform accounts, which have all of the centralized workload that I talked about, from like Kubernetes clusters, from like ingress model, from anything that it's shared across multiple services. Then we get to team accounts. Like each team gets a set of accounts that they can create resources that available to their runtime. And basically these resources like RDS instances, S3 buckets, SQs, and Elastic Cache instances, and anything that they need to run their application. So how we get all of this connected? Basically by adding a transit gateway layer between all of this. So to manage this, that might look complex, but like AWS provide like a set of services that we can use to make this experience better. So we are using AWS Control Tower with AWS Organization to manage the entire provisioning experience. And also we have CloudTrail enabled in all accounts to ensure that we understand what kind of API calls are done in these accounts. And everything here is done through a single sign-on on AWS. So that's our multi-account architecture. Let's go to another dilemma that we run through, and many of you would run through. So let me ask a question. If you are running an EKS clusters, who here like runs multi-tenant clusters versus like single-tenant clusters? Who is running multi-tenant clusters? Oh, wow, great amount. Who's running single-tenant clusters? OK, so I'll get through it. So there's a dilemma when you think about like how you build your own platform. Like either like I would go like multi-single tenant clusters, or we would go to multi-tenant clusters. And there's no one size fits. There's no one size fits all. Like it's a problem that it can be solved through many ways. Each approach has its own pros and cons. When we talk about multi-single tenant clusters, you know that there's hard tenancy. You don't have to think about like RBAC between tenants because each tenant gets their own clusters. But there's more work, more overhead in management and upgrades and all of that kind of work. And there are also like less cost optimization. If a team needs just to deploy a couple of services, you have to build a cluster for them. While when we go in the multi-tenant clusters, you get single clusters or a few clusters that share between tenants. So you get like highly cost-optimized clusters, but you have to think carefully about how you ensure security and network isolation, and all of that has to be planned before. So in our use case, we designed and have some design requirement that we built for the platform, and we ended up designing and choosing a multi-tenant clusters for our use case. And with that, if we decided to move from a multi-tenant cluster to a single-tenant cluster for a specific use case, we can do that over the course of developing the platform. So how did we deliver a multi-tenant clusters built on EKS? Basically, we have, so the picture here, or the diagram here, shows like a single environment. What I mean by environment is dev, staging, production, or any other environment you could name. So we have like multi-regions, at least 2 regions that we run our clusters in across multiple availability zones. That's to ensure that we have like maximum availability for all of our workloads. And that's where our EKS clusters run. And then tenants get access across all environments to all clusters to specific namespaces that they can use for their workload. And as you can see, we are using like different open source technologies and tools, Cilium for network policies and leveraging eBPF for routing, Carpenter for our scaling. It gave us more flexibility on how we deliver like spot instances versus on demand, and also things like if we decided to like go to a custom route and deliver node pools, we can do that with Carpenter. We're using Istio for our service mesh with combination with Cilium on cluster mesh, so we combine both to achieve native routing and availability between clusters. And at the end, we use Open Policy Agent to ensure that policies and mutations and validations are here across the board. So now, let me walk you through how the onboarding experience looks like from an account perspective. So imagine we have a team, and they don't have anything on the platform yet. They are brand new. They are our beta users. How this would work. So we are using Backstage as our internal developer platform portal. So they would go to Backstage and request, hey, we need an account. So how can we create one? They request it, they set few like information in a form, and then they go through the process. And the process here will go in depth onto how this onboarding experience looks like, but basically they go through a control tower, which the account is provisioned, then they get to like being onboarded to the shared Kubernetes clusters. So let's dive into each step. First, once the request is submitted, that gets to a control tower, which will just create the account and get it provisioned. Once it's provisioned, we're using infrastructure as code over the board. So we'll start to create the VPCs required, AWS backup settings, config rules, everything necessary here. And then you remember earlier, I talked about transit gateway. Then there's another process that will like have infrastructure as code, which will connect that specific account to the shared services. Like we have to ensure that there's no networking leak between all accounts unless it's necessary. So we have to just connect them to the shared services and make sure that we have enough network isolation, which is achieved by Cilium at this point. Last step, we connect all of that by AWS single sign-on. So teams get access to the accounts through the console or the API or the CLI. So that looks familiar, seems like the previous slide, but the addition here is that now we give teams infrastructure as code for their accounts, and also we give them access to the management console. So that's the first step. Now accounts are being created, where EKS gets a part here. So now we look at how, after the account is being provisioned, we are using like event-driven architecture to onboard these accounts to the EKS clusters. Basically, we get a message, say, accounts created. It's different from provision. Provision means like account is just available, no resources in it. But like created, it means like all the resources are being added from networking and other things that we need. And that goes through like a step function, which trigger Lambda, basically does some logic to ensure like we have all of the resources that we need for that specific account and keeps a retrying mechanism into it. And that pushes to like a repo with a CRD basically for a controller, which we call the tenant operators that we created internally. And what that does basically is just like, once we say this account needs to be onboarded to the clusters, it will just like create like tenant, namespace, network policies, RBAC, and certificate. So all necessary steps to ensure that tenant can just start deploy services and applications to the platform. But the most important thing here, we are using like another operator from IAM, which is going to create the tenant role. So basically how we grant tenant access to the clusters, basically we know already their account information. So we already take this, create an IAM role in the account, map this to their configuration, and ensures that they can get access to the cluster. So now, all of this together, we added another thing, which is a platform CLI. So that's also a CLI that we built internally that helps teams to go through all of the steps necessary to get access to the cluster. So basically, it's one command that gets you access from like AWS account, cluster, setting your context, doing all of the necessary things that you can do. And from here, like you can see, this is an experience done once, basically, when you just like go through like building a new account. But we have a similar experiences when you also build other apps. And like we can use the platform CLI for other things, for debugging, for access, for other things that you can go through while you are building on top of the platform. So what we have today. This is what we have today. This is our internal developer platform offering. And basically, it's the same that as the workflows that I mentioned earlier. It goes through the onboarding. So we have a template engine that templates all of the resources needed for a service. You get through Get, you get a GitHub repo, your CI, and then your CD goes through Argo CD, and then deploys to EKS and get configured to your tenant account, and then connected to your ingress. And then the backstage and the observability layer is cohesively looking around the entire platform. Okay, so what's next for us? So we're looking for a few things. More managed add-ons or like managed service by AWS. Hopefully one day we can see like a managed Istio instead of us managing Istio. We would love to see like a managed Istio. manage Carpenter. It's been a thing that how we manage Carpenter deployment and gets conflict. So I would love one day to see there's an issue on the container roadmap around like how Carpenter could be deployed as a control plane. Currently, we only support like x86 workloads, but we would love one day to add ARM. We are in proof of concept for like doing this on the same clusters. Better IAM provisioning process, like instead of like dealing with a config map and all of the processes needed just to like onboard new tenants to the clusters, we'd love to have an API around this. And the longer term and the future would be like to bring more workloads. So now we are looking at stateless, stateful, like API and application and jobs, but in the future we're looking into like add more data-intensive applications and machine learning to the platform. With that, I would love to share a couple quotes from my peers. So Bella, she's a senior software engineer from the games team, and she's here talking about like launching the newest game, Connection, on the platform, and she talks about like how quickly they would be able to transition from a prototype to like something in production quickly. And then Jorge, he's a staff software engineer from the publishing team, and he also talked about like how we develop and deliver many features out of the box, like deployment of pull requests and other things that would help them to focus on building their application without thinking of like how to manage the infrastructure, but they can go and manage the infrastructure when it's needed. So at the end, as I tell you like about the journey today, what we learned through this process for the previous years. User documentation, it's important. Like if you deliver a platform without user documentation, usually you will get a lot of support questions around like how I would do this simple thing. So it's critical and pivotal to deliver a good user documentation and experience to your users. Adoption and partnership. Like a platform without adoption is a waste of time. So if you built a platform as Roland mentioned earlier, and no one is using it, that's waste. So we have to partner with teams. We have to get early adopters to use and tell us like what exactly they need to build into the platform. Platform as a product. One of the critical elements that I talked to other engineers and heard from them that platform engineering is not a project. It's not a one-time thing that you go through. It's an iteration. So it's done at multiple levels and multiple iterations. So you have to do like one iteration, and things might go wrong, and you have to iterate and get through it. And at the end, customer feedback, which is critical. So you have to always keep the door open and be open-minded and looking for a change. You are not building a platform to deliver a cutting-edge technology. You are building a platform to help your customers, which is the engineering teams, to deliver their services. With that, I would like to hand it over to Kevin back.
All right. Excellent. I don't know if my mic is on now. That's all we have for you today, folks. I wanted to thank, first of all, thanks Ahmed and Roland for doing this. Thank you all for joining us. We'll get you out of here a couple minutes early so you can go to that reInvent happy hour. We're going to stick around on the stage over here to answer any questions if you have. If you have some time, we'd love to hear about the platforms that you all are building, and obviously we'd be happy to answer any questions. But with that, thank you all. Have a great reInvent.